Welcome to the Wireless News Desk for October the 11th, 2019. You probably noticed that I said it's the Wireless News Desk. We are relaunching here in October of 2019 with a new name. It's no longer the Wireless LAN News Desk, but it's the Wireless News Desk. Of course, we'll cover wireless LAN technologies as well, but we'll also be covering non-wireless LAN technologies as we move into the IoT area. And we want to begin covering other technologies that are not necessarily 802.11. Wireless LAN in the Wi-Fi community has become synonymous with 802.11 wireless networks. But technically speaking, the term wireless LAN should refer to any local area network that uses wireless technologies. So this would include IoT networks that are using Z-Wave or Zigbee, Bluetooth, or any other technology as well. So we'll be reporting on things related to all things wireless as we move forward. Now, this week, specifically on the Wireless News Desk, I want to talk to you a little bit about some IoT device concerns. First of all, in the news reported at techradar.com, the statement is that IoT devices could be asbestos of the future. Now, what are they actually saying? What they're saying is that we're installing many devices. There are around 7 billion or so that are deployed now, and the expectation is 40 billion by 2025. And not all of these devices are secured. In fact, a large number of these devices are not. Much like asbestos, when it was first used as a building material several decades ago, it was thought to be very beneficial because it provided benefits to the environment, we thought. Then we found out it caused cancer. Well, the analogy here is that these IoT devices that are deployed without security are potentially going to be causing us a cancerous security problem of the future. Now, speaking as someone who has had cancer myself and fought the battle with it and thankfully won, I am very well aware of the seriousness of this analogy. And the reality is that it is quite serious. If we have not several, but dozens of devices in a home, thousands of devices in an enterprise, and a significant percentage of these are not effectively secured, this can be a real problem for our future. And the reality is that probably as many as 70 to 80% of devices being deployed, even in the business world that are IoT devices, are not necessarily as secure as they should be. In fact, in another report, enterprises are leaving IoT devices vulnerable to cybersecurity threats, finds nCipher Security, reported at IoT Now, an excellent news website for the IoT world. nCipher Security did some analysis, and what they found is that the top threats, according to a survey, were altering the function of the device, controlling the device remotely, capturing data from the device, or using the device as a network entry point. So these are the big concerns that people have. Now, interestingly enough, while they had these concerns, not everybody is focusing on security like they really should. So the issue is that given that we're going to have 40 plus billion devices by 2025, and these devices will generate 79.4 zettabytes of data, there is a big concern because not everybody is using encryption properly. Not everybody is using security from the ground up, meaning security at the hardware level and then at the protocol level as well. We run into some challenges. Now, the suggestion is, of course, using PKI, a public key infrastructure, is a key solution for security in IoT devices. However, not every IoT device is powerful enough to use just standard PKI solutions that we might use in a desktop or laptop or even tablet or phone computer. And so we have to make sure we come up with methods that are effective and work well for these devices. Interestingly, in this report, they also found that while many organizations are wanting to use PKI and are wanting to secure their IoT devices, they found that many organizations are not doing what's needed for security. Now, one of the things that's important to note is hardware security modules used as an IoT root of trust jumped significantly over 2018. It went from 10% to 22% of devices. In addition, they found that 44% of respondents believe PKI deployments for IoT devices will consist of a combination of cloud-based and enterprise-based implementations. The most important capabilities for IoT in 2019 related to PKI are scalability to millions of certificates and online certificate revocation. So clearly there is a move toward the use of PKI when it comes to security in the world of IoT. So we want to make sure that we are very familiar with public key infrastructure, how it works, and what we might utilize that for. Now, interestingly enough, it's also important to note that respondents rated delivering patches and updates to IoT devices, which is stated here as the capability that protects against that top threat. They rated it last on a list of the 5 most important IoT security capabilities. In other words, organizations said, well, we've got to protect our environments. We've got to make sure IoT is secure, but they rated very last the thing that is key of importance, protecting the devices through proper patches and updates. And so clearly some education is required. Now, the last couple of things I want to share with you are some tools. So first of all, this is a great tool. At $149 USD, you can get the Z-Wave Toolbox, model ZWP TBX. Now, why is this cool? Well, first of all, Z-Wave works in the 900 megahertz frequency band in the United States, and this frequency band is very commonly used for IoT solutions, not just Z-Wave, but other IoT protocols as well work in this frequency band. Now, this can do packet analysis for Z-Wave specifically, which is very useful. But in addition to that, notice that it includes a spectrum analyzer. Now, this is probably one of the least expensive spectrum analyzers you can get your hands on for the 900 megahertz range. It works in such a way that you take it into an environment, power it up, and then connect to it through an Ethernet port or through a wireless connection, and then you can use the spectrum analyzer that's built in. Now, it is important to note for this specific device, if you scroll down in the page, and actually it's in the documentation. If you go into the documentation for this device, you'll see they rate the chip for 10,000 switches. That's switching from protocol analysis to spectrum analysis. So it is important to keep in mind that if you do a lot of switching back and forth, they expect the device to stop functioning eventually, about 10,000 times. Now, that's quite a lot of times, and assuming that you don't do it more than twice a day, that means it's going to last you several years. But if you do it 10 or 12 times a day, then it's going to last you maybe a year and a half to 2 years. So clearly, this is a device that may have some issues there for someone that uses it very heavily. But for those that use it just once or twice a week or even once a day, you're going to get several years of use, even with that degradation in capability based on the switching issue. So this is a very useful tool. You can see again the spectrum analyzer. It also has a network health tool where you can see a network map, and you have the signal strength in dBm, so you can be measuring the signal strength of devices and so forth. So very useful tool to utilize. And here you can actually see the tool just plugged into power, turned on in a space, and then you're seeing the spectrum and protocol analysis features. Now, the important thing to keep in mind is, again, the Z-Wave protocol is very common in consumer space, but not as common in enterprise, though it has been making inroads into the enterprise in the last 12 to 18 months. And I do expect that to continue because it is an established protocol, and they have enhanced the security quite a bit in some of the newer releases of the Z-Wave protocol. So because of that, it's looking more appealing for enterprise deployments. But remember, it scans as a spectrum analyzer that frequency band that's commonly used in the 900 megahertz range. So it's a great tool to have in your arsenal for very low cost. Finally, I want to talk to you about the Edge Community Dev Kits. Now, what these are add-ons for Raspberry Pi. And specifically, it's the Grove PI Plus sensor kit. And what this gives you is this riser board that you see right here. This plugs into the Raspberry Pi, and I know I'm kind of using an old term when I say riser board. The new term is add-on boards. I'm kind of dating myself to 1980s terminology, but the concept is the same. This board plugs into the Raspberry Pi and rises above the Raspberry Pi board, so technically it fits into that category of a riser board. But it's an add-on board, and what it does is it allows you to connect sensors to the Raspberry Pi very easily through these various connections that you see around the board. And the sensors that you can get include temperature and humidity sensors, rotary angle sensors, light sensors, sound sensors. There's an LCD panel that you can get for it. It has simply blue, red, and green LEDs. There's a buzzer, a relay, a button, an ultrasonic range detector even. And so all of these are sensors that can be added on so that you could build your own wireless sensor, or wired sensor for that matter, using the Raspberry Pi. Therefore, with this kit and a Raspberry Pi for under $200, you can actually build some pretty interesting sensor solutions. And it's great for lab testing and for those one-off type of sensors that you might need to build for an environment. I wouldn't use it for mass production simply because using something like Raspberry Pi as your main board for a mass-produced device that's going to have tens of thousands of units made is probably not the best solution in most cases because of the life expectancy and availability of a particular device like this. But still, great for both learning about IoT devices and for building real-world IoT devices that you can use in enterprise and consumer space deployments. Well, that's all I have for the Wireless News Desk here on October the 11th, 2019. Thank you for joining me, and I'll see you next week.